Welcome, geometry students, to the homework help video, page 227. Let's go ahead and get started with the problems for today. Let's start off by looking at numbers 1 through 6. Numbers 1 through 6. Here we go. Okay. We want to answer whether OB is a perpendicular bisector, an angle bisector, a median, or an altitude. So here we go. Here's OB right here. Okay? Here's OB right here. Okay. We are told that MO right here is congruent to OP. Now, that would make OB a perpendicular bisector if we knew that it was perpendicular, but we don't. So what we know then is simply that this line here comes from the vertex and hits the midpoint over here. I know this is the midpoint right here because this segment here is congruent to the segment here. So OB is a median. A median. Okay, moving on to number 2. We are told that OB is perpendicular to MP. So here we go. We'll come down. And we know it's perpendicular. Now listen, we do not know, students, that the segment here is congruent to the segment over here. We don't know that, okay? So we cannot say it's a perpendicular bisector. So what type of segment runs from a vertex and is perpendicular to the opposite side? Well, that's an altitude. Altitude, okay? Okay, moving on to number 3. We are given that angle MBO, this angle right here, is congruent to angle PBO, this angle right here. So that means this line coming down right here cuts this big angle here right in half. So what type of segment cuts an angle in half? Well, that's an angle bisector, okay? Angle bisector. Okay, moving on to number 4. OB is perpendicular to MP, so we have a right angle here, and the segment here is congruent to the segment here. Well, if OB is perpendicular to the other side, which it is, and it hits at the midpoint right here, so that this segment here is congruent to the segment here, then we call this segment here OB a perpendicular bisector, okay? Perpendicular bisector. All right, moving on to number 5. Given that triangle MOB is congruent to this triangle over here, what do we know about OB? Well, this is going to be fun, okay? Watch this. If the two triangles are congruent, let's mark all of their congruent parts, okay? So this side here is congruent to the side here. This side here is congruent to the side here. And this side is congruent to itself. This angle is congruent to this angle. This angle here is congruent to this angle here. And this angle here is congruent to this angle up here. Now, let's start with each one. We have what? Medians, altitudes, angle bisectors, and perpendicular bisectors. Let's start with a median, okay? A median has to run from a vertex and hit the opposite side so that this segment here is congruent to the segment here. And that happens, look, this segment here is congruent to this segment here. So it's a median. Now an altitude has to run from a vertex in such a way that it's perpendicular to the other side. Well, Mr. Error, we don't know these two angles are perpendicular. Yes, we do. Guys, we have a straight line here. So we know these two angles together have to add up to 180. And they're congruent. So if they're congruent and they have to add up to 180, that's 90 and 90. So sure, we know they're 90 definitely. So yes, it's also an altitude. Okay, now look at this. Angle bisector. Well, does this line right here come down in such a way that divides this big angle here up into two equal angles? Yes, it does. Look. This angle here with one dot is congruent to this angle here with one dot. So we also have an angle bisector. Okay? So definitely. You're going to see it ends up being all of these, okay? And then look, perpendicular bisector, well, we already established the fact that OB is perpendicular. And we know it's a bisector because this segment here is congruent to the segment over here, so it's also a perpendicular bisector. Okay, so there we go. So can a line be all four? Well, most definitely. We just showed that it can be in certain situations. Okay. Okay, continuing on. BO right here bisects. BO bisects angle MBP. So this whole angle here is cut in half by BO. Okay, so yes, this angle here is congruent to this angle here, so we have an angle bisector. Okay, angle bisector. Okay, moving on to number 7 through 10. 7 through 10. We're going to answer true, no, always, sometimes, or never, okay? Always, sometimes, or never. Here we go. A median always, or a median has a midpoint, has an endpoint. That's always true, guys. Think about it. When you have a triangle and you draw a median, it's always going to start from a vertex, and it's always going to run to the midpoint of the other side. So will a median always have a midpoint as an endpoint? Yes, it will. Always. Most definitely. Okay, number 8. An altitude lies outside a triangle. Well, guys, sometimes that's true. Look, if I have this triangle right here, and I want to draw the altitude would obviously lie inside the triangle. If I have a triangle that looks like this, then the altitude here would have to come down like this and be outside the triangle. Okay, so sometimes an altitude sometimes lies outside of a triangle. Okay, sometimes. Okay, number 9. A perpendicular bisector has a vertex as an endpoint. No, not always, okay? Let me show you, okay? A perpendicular bisector has to run from, I'll show you an example. I'll give you an example. A perpendicular bisector has to run from a side so that it's in the middle and perpendicular. So this perpendicular bisector here, from this side, we'd come to the middle and then go straight up so that it's perpendicular. There. This segment here that I just drew, we'll call it segment AB, is a perpendicular bisector. There we go. But is either one of its endpoints at a vertex? A vertex is this, or this, or this. Is this point here at a vertex? No. Is this point here at a vertex? No. Not at all. Okay? So you're saying, oh, so it never happens. Well, I didn't say that. I'm showing you that sometimes it doesn't happen. But what if I drew an isosceles triangle like this? Okay, in which this side here was congruent to this side here. That when I drew this straight down like this right here would be perpendicular, and it would hit right at the midpoint. So in this case here, the perpendicular bisector did come from a vertex. So sometimes a perpendicular bisector has a vertex for its endpoint. Sometimes, okay? All right. The angle bisectors of a triangle intersect at a single point. In other words, the angle bisectors are concurrent. They all intersect at one point. That's always true. Guys, we talked about that in your notes. Angle bisectors perpendicular bisectors, altitudes and medians are all concurrent. All of them meet at one point. Okay? All of them. So always, okay? Okay, let's take a look at numbers 11 through 14. 11 through 14, we're going to say true or false. And we're going to draw a picture of it also, okay? So here we go. A perpendicular bisector can also be an altitude. Well, I just gave you an example right back here. Here it is, okay? This is an altitude because it runs from the vertex to the opposite side, and it's perpendicular. That's all that altitude has to do, students, is run from a vertex so that it's perpendicular to the other side. But also, this line here is a perpendicular bisector because it hits the midpoint. In other words, this segment here is congruent to the segment here. And not only does it hit the midpoint, it's perpendicular. Okay? So, is it possible that a perpendicular bisector can also be an altitude? Yes, definitely. Okay, number 12. An incenter can also be a circumcenter. Okay, now let's talk about what an incenter is. Okay, the angle bisectors of a triangle are what make the incenter of a triangle. Okay, a circumcenter is the point where your perpendicular bisectors intersect. So it's possible for your three perpendicular bisectors and your three angle bisectors to all intersect in one point. And I say yes, it is definitely possible. Okay, that would be true. Let me show you how. Okay, draw an isosceles triangle. Draw an equilateral triangle so that all the segments here are the same, congruent. Now think about it, guys. Draw your three angle bisectors. Okay, these lines are theoretically cutting the angles in half, okay? Now draw your perpendicular bisectors. Well, guys, these are your perpendicular bisectors. They would come straight down because an isosceles triangle, this point here is right in the middle of this side here. It's straight up and down. So if I draw the perpendicular bisector, it would be right here. If I do the perpendicular bisector from here, it would be right here. And if I do the perpendicular bisector from here, it would be right here. So there we go. So all six of those lines intersect in the same place. So yes, that's true. Okay, number 13. An angle bisector can be a median. Okay? Now, an angle bisector cannot be a median. Okay, that's false. I mean, not every angle bisector is a median, but we can definitely draw a triangle so that an angle bisector is a median. In fact, we just did it. I'll do it again for you. Draw an isosceles triangle. This side here, the side here is congruent to this side over here. Now draw your angle bisector. Cuts the angle in half, but it also hits the midpoint over here. So, definitely. In fact, let's go all the way back to number 1 through 6. Remember, we had in question number 5, we had a line here that was all 4. Remember? 1, 2, 3, 4. All right, so it's definitely possible to have an angle bisector that's also a median. Okay, definitely. So that's false. Okay, number 14 says the circumcenter is the center of the inscribed circle of a triangle. Now the circumcenter again is the point that contains the perpendicular bisectors. Okay, so this is false. Okay, now a circle inscribed in a triangle means this. It's a circle. How can I say this? It's a circle inside of a triangle. And of course, if a circle is inside of a triangle inscribed properly, it has to touch each side of the triangle. So you have to find a point that's equidistant from all sides of the triangle. Now this is a tough one to answer, so listen carefully, okay? Now watch. This would be an inscribed circle right here. Not a very good one. I'm not a very good drawer, you guys know that, but okay, there we go. Now this distance from here to here, and from here to here, and from here to here, all has to be the same because they're all radii of the triangle, of the circle. All three of these segments are radii of the circle. Now, listen carefully. I taught you guys during class that there's a point that's equidistant from all sides of the triangle, but it's not the circumcenter, guys. Look at your notes, okay? It's the incenter, okay? The incenter is always equidistant from the three sides of the triangle, and the incenter is the point that the three angle bisectors make. And this doesn't say the incenter here, it says the circumcenter. So this is false, guys. The circumcenter might be the center of a described circle. It might be in some occasions, okay? But is it always? No. You cannot say the circumcenter is the center of the inscribed circle of a triangle, okay? You cannot say that. You can say the incenter is the center of the inscribed circle of a triangle, okay? But not the circumcenter, okay? All right, number 15 through 19. Here we go. Okay, okay, let's go through and do this, guys. In the directions, they give you some different information here. And they tell you that O here is the centroid. Okay, now remember, a centroid is where the medians intersect. So if this is the centroid, then I know that this is the median, this is a median, and this is a median. Now remember, medians go from a vertex across the triangle in such a way that it hits the midpoint. So if DG is 7.5, then GE is also 7.5. I'm gonna go ahead and write that down. Okay, and 9. If DH is 9, then HF is also 9. All right. Now one more thing we learned about medians and the centroid. Remember, this whole length here is set up like this. The distance from here to here is 2/3 the entire distance across. So what I taught you guys was this. The shorter distance here is always half this distance here. Okay, so if HO is 4, then OE has to be 8, and the whole length would be 12, okay? All right, here we go. Find the length of HF, okay? HF is 9, taken care of, done. Okay, 16, find the length of EO. All right, well, EO's right here, 8, okay? 8. Number 17, find the ratio of OI to OD. Well, here's OI, OD. Mr. Earhart, we can't do it. We don't know what this length is. True, I agree. But think about it, guys. Whatever this length here is, let's make a number up. Let's say it's 3. Then what's this length over here going to be? 6. What? We don't know. Okay, fine. If it's 6, then the ratio would be what? 3 to 6. The ratio of OI, 3 to OD, 6. So 3 to 6 would reduce to 1/2. Well, Mr. Arrow, you can't do that. You don't know these lengths. Okay, pick another number then. Let's say this length here is 8. So this length over here would be 16. The ratio is still 1 to 2. 8 to 16, which reduces to 1 to 2. Let's say this length here from O to I is 18. Well, this length over here would be 36. So the ratio would be 18 to 36, which reduces to 1 to 2. So either way, no matter what number you put, no matter what numbers you put for the length of OI and OD, you will still get the ratio 1 to 2. Okay? All right, or 1/2. They used a fraction here. That's fine. 1/2. Same thing. Okay? All right, moving on to number 18. Find the ratio of OI to ID. Okay, no problem. Let's just say OI is 18. Okay? ID, the whole thing would be 54. So reduce that and you get 1 to 3, 1/3. Well, Mr. Arrow, let's use different numbers, okay? Let's use small numbers. Let's call this 2. And let's go with this 4. Then the ratio of OI to DI, the whole thing would be 2 to 6, which still reduces to 1/3. So no matter what numbers you put here, students, the ratio will still be 1/3, okay? All right, moving on to number 19. Given that DE is congruent to EF, find the perimeter of this whole triangle, DEF. Okay, well, here we go. Well, this whole side here is 7.5 plus 7.5, so this whole side here is 15. That means this whole side over here is 15, because it says right here that DE equals EF. So this is 15, and this is 15. This whole side here would be 9 plus 9, so 18. So the perimeter would be 15 plus 15 plus 18, which would give you 48. Okay? So the perimeter would be 48. All right? Okay, moving on to number 22. Draw a triangle that has an altitude that lies outside the triangle. Okay, just draw an obtuse triangle like this. There we go. And the altitude, I can do better than that. Hold on one second. So the altitude for this triangle here would have to be down like this. And you would extend this side here. So there we go. There's a triangle where the altitude is drawn on the outside. Okay, letter B. Draw a triangle that has an altitude that is the side of a triangle. Okay, sounds a little weird, but it's possible. It's definitely possible. Okay, now students, if you draw a right triangle like this, a right triangle, now look, think about it. The altitude that runs from here to here would be the side right here. There it is. So in a right triangle, the altitude is actually going to be the side of the triangle, okay? All right, moving on to letter C. Draw a triangle that has an altitude. We're going to come back to this triangle here a little later. Let's put it over here for a second. Okay, letter C. Draw a triangle that has an altitude. There's also a perpendicular bisector. Okay, here we go. So let's draw an isosceles. An isosceles triangle. Or try to anyways. And this side here is congruent to this side here. If you were to draw the altitude, here's the altitude. That altitude right there would also be a perpendicular bisector. Now it's an altitude because it runs from the vertex and is perpendicular to the side over here. It's a perpendicular bisector because obviously it's perpendicular to the side, but it also hits in the midpoint. So this segment here is congruent to the segment here. So an isosceles triangle would satisfy letter C. Okay, now letter D. This is interesting. D is very interesting. Look at this. Okay, what is the orthocenter of a right triangle? Now remember, the orthocenter is where the altitudes meet. Okay, so let's go ahead and draw the altitudes of this triangle and watch where they meet. Okay, here's one altitude here. Okay. Here's another altitude right here. Okay. And here's the other altitude right here. So where do the altitudes all meet at? Right here. They all meet at the vertex of the what? The vertex of the right angle. Okay, so I wanted you to see that. And there's the answer, okay? So pretty interesting question. Okay, number 23. Draw a triangle that has a median that's also a perpendicular bisector. Well, guys, same thing, a little redundant. Isosceles triangle. Like that one there. Yes, very well done. That's even worse. Alright, here's my perpendicular bisector. Okay, but it's also a median. A median, well, perpendicular bisector has to be perpendicular to a side, and it is. And it also has to be in the midpoint, and it is. A median has to run from a vertex and hit the midpoint of the opposite side, and it does all of that. So there's an example of a median and a perpendicular bisector that are the same thing, okay? Okay, letter B, draw a triangle that has a median, there's an angle bisector right here. Same thing. An isosceles triangle will do it every time, okay? So this line here is a median, it is the midpoint here, but it also cuts this angle up here in half. So right here's an example of letter B, okay? Now letter C, can a median be a perpendicular bisector and not an angle bisector? That's not going to be possible, guys. If you're going to draw a situation where a median is also a perpendicular bisector, it will also be an angle bisector. Now you can try all you want to find a counterexample of this, but it's not going to happen, okay? If you draw a median, if you have a triangle in such a way that the median is also the perpendicular bisector, it will always also be the angle bisector. Always. Okay, so the answer is no. Just think about that. There's no way it can be done, okay? Now, letter D. Can a median be an angle bisector and not a perpendicular bisector? No, not at all. If you have a triangle drawn in such a way that a median is also an angle bisector, every time it will also have to be a perpendicular bisector every time. Now you can try again and again to draw it in such a way that that's not true, but it's just not going to happen, okay? If a median is an angle bisector, it will always also be a perpendicular bisector, okay? Always, okay? All right, moving on to number. And if you want to, play around with that and kind of see for yourself, okay? But it's not possible to do that, okay? All right, number 30, okay. Okay, for number 30, I told you to find the median that comes from vertex A. So here we go. Here's vertex A, and the median will be the midpoint right here. Let's draw that line. Now, students, think about it. In order to write a linear equation. I've taught you guys this. You need two things always. Always two things. You need a point that lies on the line. We have two of those. We have one here, and we can find this point here quite easily. So we have a point, and we need the slope. Well, students, we can easily find both of those. First of all, we have a point. Here's a point that lies on the line right here. 0, 0. Now we can easily find the slope, guys. Look, how do I find this point? Midpoint formula. Look, this point, if this is truly a median, which it is, then the median has to hit the midpoint over here. And I've taught you guys how to find the midpoint between 2 points. See this point here? See this point here? The midpoint is right here. How do you find the midpoint between these 2 points here? Here's the formula down here. X plus X divided by 2, comma, Y plus Y divided by 2. So here we go. Here's my X, here's my Y, here's my X, here's my Y. X plus X is 30, divided by 2 is 15. Now, Y plus Y, 6 plus 0 is 6, divided by 2 is 3. So there, we found the midpoint. There, just like that. Guys, we should, listen, I'm not being mean, but we should know how to find midpoints just like that. We've been over this, okay, guys? This is the midpoint formula. So, I now know this point here lies on the triangle, and I know this point here lies on, this point here lies on the red line, and this point here lies on the red line. So find the slope. Remember how to find the slope, guys? You should. Slope is y minus y over x minus x. Okay? So y minus y would be 0 minus 3. X minus x would be 0 minus 15. So you would get negative 3 over negative 15, which reduces to a positive 1/5. Positive 1/5. So now we know the slope. So now we're ready to write our linear equation. Remember how to do this, guys? We've learned this. Okay, here it is. Use this formula here. Not sure what happened to my fraction here. 1/5. Remember this formula? Okay, for y, this is my x, this is my y, this is my m. So for y, I'll put a 0. For m, I'll put 1/5. For x, I'll put 0 plus b. Okay, 1/5 times 0 is 0. This is easy. 0 plus b is 0, so b equals 0. So students, you know what your slope is. You know what your b is, your y-intercept. Write your equation. Y equals, here's your slope, plus b. There, we did it. Okay? Pretty simple. Okay, let's move on to number 31. Okay, for number 31, let's see, what did I tell you guys to do for 31? I forget. 31 says, find the equation of the altitude that comes from vertex A. Okay? Altitude from vertex A. Alright, so what we're going to do is we're going to draw a line that is that goes from A, okay, it is perpendicular to this line here. Now I'm not sure where that's going to be. It might fall on the inside like this, or the line I'm looking for might fall on the outside like this. It might come down like this. I think this is what it does myself, like this. Okay? So there we go. So I'm trying to find the equation of this altitude. Well, guys, remember, when you're writing a linear equation, all you need is what? A point and a what? Slope. Well, guys, we have a point that lies on the green line, 0, 0, because we know the altitude comes from vertex A. So I know I've got point 0, 0. Okay? Very good. Now, what about the slope, Mr. Earhart? Guys, we learned that perpendicular lines, we should know this, have what? Negative, or let's use the word opposite. Opposite, reciprocal slopes. So look, if this green line here is perpendicular to this red line here, all I have to do is find the slope of the red line and then flip it and change the sign, and I'll have the slope of the green line. Let me show you what I mean, okay? Let's find the slope of this line here, okay? I have 2 points, this one and this one. So let's find the slope of the red line, okay? Here we go. Y minus y over x minus x. So I would be left over with 6 minus 0 is 6. 12 minus 18 is negative 6. So negative 1. So there's the slope of the red line. So the red line has a slope of negative 1. Now, take negative 1, flip it. So it's really negative 1 over 1. Flip it, and you still get 1. And change the sign, you get a positive 1. So the slope of your green line has to be positive 1. Because look, guys, perpendicular lines have opposite reciprocal slopes. And we know the green line has to be perpendicular to the red line because it's an altitude, and altitudes are perpendicular. So the slope of the red line and the slope of the green line have to be opposite reciprocals of each other. So now that I know this information here, I can quickly write my linear equation. As soon as you have a point in the slope, you're all set, guys, okay? For my y, I'll put a 0. For my m, I'll put a 1. For my x, I'll put a 0. Okay? 0 equals 0. 1 times 0 is 0 plus b. So 0 equals b. So you know what b is. You know what your slope is. So write the linear equation. Here it is. Y equals 1x plus 0. Okay, there we go. Let's see if that's one of the answers here. Yes, right here. They put y equals x, which is the same thing as 1x plus 0. So there we go. Okay? All right, moving on to number 32. Okay, number 32 says to, let's go back and look at the directions here. Okay, find the equation of the perpendicular bisector that bisects side AC. Side AC, so here we go. So we're looking for your side AC right here. So we're looking for the perpendicular bisector that comes from this here. Okay, and has to hit the midpoint here. Okay, it has to go like this. Okay, now listen to me carefully. That's the line that we're trying to find the equation of, a perpendicular bisector. So if we're trying to write a linear equation of that red line, we immediately know we need 2 things. We need a point that lies on this line, and we need the slope. We don't know any of those, okay? Well, first of all, look, guys, a perpendicular bisector has to hit the midpoint. That's the definition of a perpendicular bisector. So I can find this point very quickly. Okay, it's the midpoint between this point here and this point here. And we know how to find the midpoint. X plus x divided by 2. Y plus y divided by 2. Okay, so here we go. 0 plus 18. X plus x. 0 plus 18 is 18. Divided by 2 would be 9. And then y plus y. 0 plus 0 is 0. Divided by 2 is 0. So there we go. We found that point. So this point right here is 9, 0. So we got a point. That's good. Now, how about the slope? Well, guys, come on. We know this, okay? In fact, I don't even think we need to find the slope. This is actually, we're done. Guys, we should have learned, oh, we know this from Algebra 1 and Algebra 2. Come on, guys. Remember? Let's review. Let's review. Okay? in the good old dreaded word in math review. Come on, guys, think about this. Think really hard. In algebra, we learned that a perfectly horizontal line is always just y equals. In this case, here would be y equals 2 because it passes through the y-axis at 2. We learned that perfectly vertical lines like this are going to be x equals something. In this case, here would be x equals -3 because the vertical line passes to the x-axis at -3. So look at this line we have. It's a perfectly vertical line. Is it not? It has to be because this line here is perfectly horizontal. And this line here is perpendicular to it. So the red line we're trying to write the equation of is a vertical line like this line here. It's a vertical line. And where does it go through the x-axis at? 9. So you're done. The answer is x equals 9. Please don't forget that stuff, guys, from algebra 2, okay? Remember, a perfectly, and here it is right here, a perfectly horizontal line, the equation will always be y equals a number. A perfectly vertical line will always be x equals a number, depending on where the line crosses the x-axis at, or the y-axis, okay? Okay, moving on to number 33. 2 left and we're finally done. Okay, given L is parallel to N, what is the value of x? Okay, now here's what I did. I went ahead and I extended this line here. Okay, so just bear with me here. Let's pretend this line kept going. Okay? Pretend this keeps going. Pretend this keeps going here. Okay, there we go. Now, we have parallel lines cut by a transversal. Okay, got it? So, alternate interior angles are congruent. So if this angle here is 30, this angle right here has to be what? 30. Booyah. Now, see this straight angle right here? With the line coming off of it? That means this angle here and this angle here are a linear pair. They have to add up to 180. So this angle here would be 50. Okay? Now, if this is 50 and this is 30, I have a triangle right here. Okay? 50 plus 30 is 80. So this would have to be 100 right here. Okay? So x has to be a straight angle or a straight line with a line coming off of it. So they have to be supplementary. So x has to be 80 degrees. Okay? There we go. 80. Back that up and watch it again if you need to, guys. Okay? Not too difficult. You just have to extend a line here so that you have a complete transversal cutting two parallel lines. Okay, number 34. What is a plus b? Well, students, we should see this right away. I'm going to draw it for you real quick here and we're done. Watch. Look at this. See that? That. And that. Okay? Got it? See that? Now watch this. This is 140. And this is A and this is B. Now we learned that when you have a triangle and you extend one side, this angle here is called what? An exterior angle. And these two angles here are called the what? Remember? Remote interior angles. And we've learned that the exterior angle is always equal to the sum of a plus b. So the question they're asking is, look, what is the value of a plus b? Right here, what is the value of a plus b? Well, a plus b has to equal 140 because the sum of your two remote interior angles has to equal your exterior angle. So the answer is 140. Okay, here's your answer right here, 140. Okay, guys, I hope this homework help video has been a help to you guys. If you have any questions, don't hesitate to call or email.